Hi class. Today we need to talk about something really important concept that we're going to be talking about all throughout the year, especially when it gets to the human body, but all living things need to basically be able to perform, and that is this concept of homeostasis. And you'll see some commonality amongst all living things when it comes to this. So we have to think about what is it, how do we observe it, and also what are some things that can happen if you don't follow homeostasis or have homeostasis going on. So what is it? Well, it comes from Latin, and the word homeo means the same, or homo means the same. And stasis, we have to think about, is staying or stay. And if you put the two together, homeostasis is staying the same, or the state of staying the same. So what does this idea of staying the same mean? Okay, we're not exactly always exactly the same. So think about this. Okay, so this term, homeostasis, is used for this idea of this balanced state of the body. We have certain things in our body going on that if they get out of balance, it can result in some big problems, and things like waste products and nutrients and excuse me, blood pressure, all of these things we have to keep in balance in order for us to maintain our health and to go on living. So examples could include, sorry about that, body temperature, blood sugar, water balance. We call this thing osmoregulation. Our kidneys are well designed to balance out the water. So if we have too much water in our blood, our kidneys are going to excrete that water. If we have too little, they may hold back some water. Salts, all of the water balances between the salts and the minerals, it needs to be maintained so we have proper processes going on. We're going to be talking about diffusion later on in the year, and you'll see if your salt balances are off, what kind of problems that can cause in your body. Okay, maintaining homeostasis. So how do we maintain homeostasis? We have this idea of these negative feedback loops. And if you've ever adjusted the temperature of your house is a good example of negative feedback. Well, what is it? What happens when something gets out of your range, out of the normal set point that you have? So if you think about setting your house at 70 degrees Fahrenheit, and that's comfortable to you, if your house drops below that, something's going to happen in your house. Like you're going to have the furnace. A typical thing is the furnace is going to kick on and burn some sort of fossil fuel, and that will provide heat and will raise the temperature up of your house to its set point. Once it reaches that set point of 70 degrees, it'll shut off the furnace. Then it might drop below that set point again, and then it'll kick the furnace on, and it'll raise the temperature back up, but it stops when it reaches its set point. It doesn't keep on burning and keep on getting hotter. You want it to stay at that set point. So that's that idea. You can also think about one more example when it comes to the temperature of our house is when your house gets too hot in the summertime, you may want the air conditioning to kick on. So you might set it for 70 degrees in the summer, and let's say your temperature gets to be 80 degrees in your house, or even 71 degrees in your house, or 72 degrees in the house. It'll send a signal to your air conditioning unit to kick on. Your thermostat does this. So your thermostat, you set it at 70 degrees, it gets up above 70 degrees, it's going to send a message immediately to your air conditioning unit. Your air conditioner will kick on, do its processes, and lowers the temperature of your house back to 70. Once your temperature gets to 70 degrees, then the thermostat will shut off the air conditioning, and you'll stay at that set point. But then you'll notice your house will get warmer again, and your air conditioner will kick on again. But once it gets back to its set point, your air conditioner will stop until it gets out of that set point and gets higher. So these are what are called negative feedback loops. Anything that brings it back to its normal set point is a negative feedback loop. And this might be something that we follow in our body. Let's take a look. So let's say you're in gym class and you're running around and you get hot. Okay, well, your nervous system is going to pick up that your skin's getting hot, your core body temperature is getting hot, so it's going to send a message to your skin, to your sweat glands, to release sweat. Well, that sweat is wet now, and when the sweat evaporates from your skin, it'll cool your body down. It takes heat to evaporate a liquid. So once that sweat evaporates from your skin, well, you start cooling down. Okay, so that's down here. So it cool down. And then once your body cools back down to its set point, we know that that's around 98.6 degrees Fahrenheit or 37 degrees Celsius, working with metric, which we should. You stop sweating until your body gets hot again. So let's say you run around again or you go into a hot environment. Okay, the whole cycle, and it's a cycle, and it'll start over. You'll start sweating again. Sweat evaporates from your skin, you cool down, and then once you cool down, you stop sweating. So that's a negative feedback. You're bringing your body, cooling it off back to its normal. We do this with blood sugar. We do this with water balance. Once you bring your body process back to normal, you stop doing it, or temporarily, and then it'll get out of its norm, and then it'll have to do that process again and bring it back to norm. This is what we refer to negative feedback, and this is how we maintain homeostasis. And so when we look at our body temperature throughout the day, this is kind of what it looks like. We might start a little low, then we go and we start running around and we get a little warmer. We might start sweating here, and then it brings it back to normal. Our temperature may even drop below normal, and then maybe we might start shivering. And then, again, that process will bring our temperature back up to its normal set point. But again, you might notice that our body temperature never really stays exactly at 98.6 degrees Fahrenheit. It stays around there, and we're constantly making these minor adjustments. You gotta get that down there too. We make these minor adjustments to maintain our set point as close as we can. And so that's where the homeostasis should be, or where our average should be, or basically that's where our set point is, and that's really maintaining homeostasis. You'll see these little tiny changes throughout the day to our processes. Okay, so that's how we maintain homeostasis, is with this idea of negative feedback loops and this idea of dynamic equilibrium, right? Equal meaning equal, but dynamic is ever changing. So we make these small adjustments, not big adjustments. We make small adjustments to maintain a homeostasis. All right, what happens if you don't maintain homeostasis? This failure to maintain homeostasis, well, bad things happen. Okay, we know that you can get sick or even die. Okay, so if somebody's not maintaining homeostasis at all, think about body temperature. If you're not able to cool your body down and your temperature goes way up to 104 degrees Fahrenheit, 105, 106, that will result in really bad things. We're going to learn about what happens to your body at those high temperatures later, especially when we get to our biochemistry unit. But for now, understand, if you don't maintain your homeostasis within a certain range of that set point, it will result in death or disease. Okay? The last thing, this is not really homeostasis. It's a different process, but this has more to do with your life functions. I think I gave this to you in life functions, but don't get it confused. Metabolism is something else. It's all of our chemical processes occurring. So homeostasis is more of that process of maintaining your body, maintaining those set points and maintaining those levels, whereas metabolism is all the chemical processes occurring. All right, that's it for homeostasis. And make sure, get these notes down, and we'll be using these later on in the year as well. Okay? All right, well, thank you for tuning in, and I'll talk to you soon.